and welcome to the final in our DevOps for the Enterprise webinar series. We've got a bit of a departure from our normal routine today in that we're running a DevOps virtual office hours for you together with some members of our AWS Solutions Architecture team here in Europe. So the format today set for today's session is going to be slightly different from normal in that we've got some topics that have been submitted to us during the course of the series, which we're going to be focusing on with answers during today's session that are going to be delivered for you in the form of a series of short presentations by the team of essays that we have on the line today. Of course, you can also submit any questions that you haven't yet submitted to us in the pre-submission process during today's session, and you can see a Q&A panel in the webinar interface. If you've got any topics over and above the ones that you can see on the slide in front of you that you'd like us to cover today, we intend to use the full hour, so if you've got anything you'd like us to talk about, please submit questions during the session. Brian, who's on our team today, will be answering your questions live in chat, so you'll be receiving answers straight away. We might pick out some of the more interesting questions if we've got some time left at the end of the session to focus on, with some further answers that we might cover today on a sort of ad hoc basis. So that's the sort of plan for the session. Let's get started with the first topic that we have for you today, which is about AWS Cloud Formation. And this is something that we covered in a little bit of detail during the earlier sessions in this series, but we also had some questions submitted about it. Cloud Formation, just quickly recapping, it's a service that AWS provides that enables you to programmatically create AWS services. So you create a Cloud Formation template, which is a JSON notation file. That template's executed through the Cloud Formation engine, and the definitions within that template will be used to create a collection of AWS services for you. And that can encompass pretty much every service that AWS offers today. And you can also use that engine to manage updates and, of course, manage clear down of those services once you've created them. So it's a good tool for managing environmental refresh, keeping your environment in a consistent state, and also allowing you to manage large numbers of environments without any of them being left orphaned. In other words, you've been left with charges for environments that you're no longer using. You can find out more about it at aws.amazon.com/cloudformation. That's the product detail page on the AWS website. And we recorded an hour-long masterclass webinar early this year where we focused solely on CloudFormation and talked about some simple and advanced topics for using CloudFormation to manage and control your AWS services. And you can find that at the URL that you can see on the screen there. I recommend you take a look at that if you're not familiar with CloudFormation. It's a useful primer. And of course, you can get these materials from the files link that you can see in the webinar interface. So don't bother making a note of those. If you're interested in following these links or other links that you might see during the session today, just grab the materials and you can click through to the links from the materials if you're interested in following up on any more detail. Specific questions that we had that came out of the previous sessions in the series. We were asked about helper scripts, to talk a little bit about helper scripts. And CloudFormation provides these helper scripts to help you manage bootstrapping above the AWS services layer. So really to enable you to do something with your EC2 instance after it's been created by the CloudFormation engine based on the template that you've defined. And in order to make use of these helper scripts, you have to do something, which I'm going to show you in a second. But in essence, helper scripts allow you to do things like manage packages that you might want to install into your EC2 instances, or expand source files that might contain application assets, static or dynamic application assets, and do a number of other things as well, which we're going to come to in a second. Bootstrapping helper scripts. Well, in order to bootstrap the helper scripts themselves, you need to embed the stuff that you can see in bold in this CloudFormation template here into your templates. So this will install the CloudFormation helper scripts with that yum update command that you can see there. And it will execute the CFN init script, which is the first of the helper scripts, which will essentially kick off the other scripts as required and allow you to make use of these additional keys that you can place in your CloudFormation template files. And these keys can take a few different forms. Just by way of a couple of examples, you can use the files key that you can see in this sample here to create text files on the instance file system. So you might use this to dynamically create, for example, here you can see a MySQL setup file which is being created. And we can create references and make references inside this construct within the CloudFormation template in the same way that we can with any other CloudFormation resource that we might create. So you can dynamically populate configuration files with information from elsewhere in your template. So if you dynamically created an RDS instance, for example, you could reference the name of that dynamically created RDS instance within your files key section to make sure that the MySQL setup files that you were creating pointed back at the right RDS instance that you just created. So it's a pretty powerful tool from that respect. You can also, as we've already said, deal with services, not only the installation of services, but also enabling and ensuring that services are running, in other words, starting on startup on first boot, services that you specify in the services key. So it's a pretty powerful tool. You can find out a whole lot more about CloudFormation helper scripts if you visit the reference that you can see at the bottom of this slide. There's a comprehensive set of documentation there that can help you with bootstrapping instances above the CloudFormation services layer. And of course, all that functionality is available on Windows as well. And Lee's going to talk in a second about bootstrapping Windows in more detail. So I'm not going to steal a lot of his content, but you can use that exact same functionality on Windows instances in the same way you can with those examples that I just showed you on Linux. And of course, there are other tools that you can use for bootstrapping above the EC2 instance layer. Popular ones include, of course, Chef and Puppet. And we provide a comprehensive set of documentation for bootstrapping Chef and Puppet agents using CloudFormation at the URL that you can see at the bottom of this screen here. So if you visit that CloudFormation articles and tutorials page, you'll find some really good documentation there about how you can use CloudFormation to bootstrap other configuration management tools, Chef, Puppet, and some others as well, actually. So take a look at that reference if you want to use those third-party configuration management tools. Another question was asked about nested stacks, and this is a powerful but very simple feature. So it enables you to essentially nest stacks. So you can have within one CloudFormation template a reference to another CloudFormation template. It's very simple to do. Just define it in a CloudFormation object in the way that you can see here as a resource. So this resource would be of type AWS CloudFormation stack, and you would define its properties. And the most important thing there really is that template URL that you can see, which will point out to a location on S3 where you will have stored the stack definition, the template that you want to reference in this nested stack. And again, there's a full set of documentation there that you can find at the bottom of the screen. It's very simple, but a powerful tool for enabling you to componentize your templates and improve the level of reuse that you might be able to get out of these resources once you've created them. So you can make use of nested stacks for that particular use case. We had another question about creating CloudWatch alarms. Again, this is pretty simple to do. So you can create the AWS CloudWatch alarm resource type. It's important to take a look at the second reference that you can see here, which is about Amazon CloudWatch namespaces, dimensions, and metrics. And that's probably beyond the scope of the session today because it's quite detailed, but that really tells you everything you need to know about what you can create alarms about. For example, you could create an alarm about an aggregate metric, which is measured off a complete autoscaling group. So for example, the aggregate memory utilization in autoscaling group would be quite a common metric to create, and you can do that using those namespace dimensions and metrics that you can find in the Amazon CloudWatch developer guide. Visit the page at the bottom of the screen here, and you can find that developer guide for CloudWatch linked off that. And finally, I think custom resources. So this allows you to define non-AWS resources within a CloudFormation stack. So you could, for example, write your own service which created some other non-AWS resources. You could call that service as part of your stack creation process, and that could kick off the creation, for example, of, say, external service endpoints that might be delivered to you as a service by a third party, writing what is essentially a shim between CloudFormation and that third-party service creation API, and then calling that out of a CloudFormation stack. So you can do some super powerful stuff with that, as you can probably guess. Again, we could talk for probably an hour to 2 hours just about that particular topic area. So rather than do that, if you check out that video, which is the first of the two links that you can see at the bottom of the screen here, you'll find a pretty detailed discussion of custom resources that was recorded in a video session at last year's reInvent. So we're talking about November 2013 here, but the principles and examples that are given within that video are still current and still very relevant. So take a look at that video if you've got 40 minutes to watch it, learn a little bit about custom resources with CloudFormation. We've also got a walkthrough with detailed documentation that explains how to create your own resources and how to reference them, which once again you can find on the CloudFormation documentation site. Okay, so that pretty much concludes what we've got on CloudFormation. I'm going to hand over to Lee now, who's going to talk to you briefly about bootstrapping Windows instances.
Thanks, Ian. So I want to talk about bootstrapping Windows instances, and Ian has already touched on talking about bootstrapping instances for Linux. For Windows, it's very similar. There's not much difference, but we're going to talk through how we can bootstrap Windows both directly with EC2, managing your EC2 instances, but also with Cloud Formation and also for Elastic Beanstalk as well. So moving on to Amazon EC2. So this is when you're creating an instance directly yourselves through the API. On every Amazon AMI for Windows, we have what's called an EC2 config. It's a Windows service and it's running on boot up and it's running all the time. And it will execute scripts that appear in the user data script. So very similar to a Linux where you can create a bash script to run and install and configure your instance. With Windows, you user data use these two here to format a particular script to run. So if the user data starts with and ends with a script tag, then the EC2 config service will use command.exe and run that as basically as a batch file. If you use the PowerShell tag, then it will be run against the PowerShell application. So both of these two alternatives, but they both accomplish the same thing. So you can run scripts within your Windows EC2 instance on boot up of the first boot up, allows you to configure your Windows instance, install, configure, download files exactly as you would in a Linux instance. And just to give you a quick example, here we've got PowerShell, a PowerShell user data script. Very simple. It's just, as you can see, it's just creating a file and saving hello world into it. This gives you the idea. Moving on to Cloud Formation, Ian has talked about helper scripts for Linux. We have the equivalent in Windows. So for instance, cfn init in Windows is an executable called cfn init.exe. And you can use this to run and extract data out of your metadata out of your Cloud Formation init within your resource template definition. The cfn init, again, is a executable that is run within your user data script. So you still use, previously on the EC2, you use your script or your PowerShell to run the cfn init exe. And in Windows, it's very similar to Linux. You're able to download files, you're able to download source zip files and unzip them into the directories you specify. You can specify commands to execute. These all run against command.exe. So if you have PowerShell scripts that you want to run, you can still do it. You just need to use command.exe and use PowerShell.exe to actually run the script. Also with the packages, obviously on Windows you don't have yum to run, for instance, but you have got the MSI packages. So you can actually download and install MSI Windows installer packages. And you can also configure Windows services to start and to restart. Onto Elastic Beanstalk. Now, very similar to CloudFormation, primarily because Elastic Beanstalk is built on top of CloudFormation. So again, you've got quite a lot of bootstrapping capabilities within your .NET Elastic Beanstalk container. This works slightly different. So within your source bundle, you will have a .eb extensions folder, and within there you can create multiple .config files. And these config files are run by Elastic Beanstalk in alphabetical order. And within those files, you create a YAML definition, which will describe files that you want to download, again, source files that you want to download and unzip. You can run commands, again, via command.exe, and you can specify whether these run before the application is installed and also can be run after every application version deployment. Similarly, with CloudFormation, you can also install MSI packages, and you can also configure Windows services. Additionally, within Elastic Beanstalk, you can also configure Beanstalk and also set environment variables that can then be used within your application itself. So those three ways of how you can bootstrap Windows instances, very similar to Linux, but they are a little bit Windows specific. And now I'm just going to hand you over to Andreas, who will the OpsWorks event cycle.
Hi, everyone. So one of the questions that we received was around OpsWorks and what precisely happens when a new server is launched via the OpsWorks service. So these are the different lifecycle events. This is how OpsWorks manages the lifecycle of an instance. So initially we have the setup event, and this is where a new instance is brought to life, and this is what happens after it has finished booting. We can allocate specific recipes to that, so that when an instance boots, it runs all the bootstrapping actions that need to happen. So this is where we would, for example, configure a recipe to install Apache or MongoDB, etc. And when we run the setup event, there is a specific order in which the recipes are executed. First, we are running the OpsWorks setup recipes. These are the default recipes that OpsWorks needs to run first. And then we run the recipes that you configure under the setup event. After that, you might have deploy recipes. We're going to talk about this lifecycle event in a bit. And again, the order is first we run the OpsWorks deploy recipes and then your own deploy recipes. Now, the order in which your recipes are executed depends on how you have configured them, in which order you have configured them in the panel, in the application panel on OpsWorks. If you want to override that, you can create your own wrapper recipe that will define exactly in which order you want your recipes to run, regardless of how, in which order you would have them in the panel. The next event in the lifecycle is the configure event. This is sent to all the instances when any instance enters or leaves the online state. So you launch a new instance, for example, an application server, but you want to go to perhaps your proxy, might be HA proxy, and you want to modify the configuration to add or remove an instance from the list of instances behind the HA proxy layer. Then we have the deploy event. So this happens every time you launch a new instance or when you release a new version of your application and you want to deploy that to all the application servers. And you can add your own recipes to this event to customize the way an application is deployed to your instances. But you also have the option to use self-deployment hooks. So this is a more straightforward way. Instead of creating a recipe, you can add a folder, a deploy folder within your application code and create simple Ruby scripts that will implement specific items that you need to prepare your application as it is deployed on the instance. When you want to remove an application from a set of application servers, you run the undeploy event. So again, you can add your own recipes here to perform actions, custom actions that are not performed by OpsWorks itself. And there is also the shutdown event. This takes place on an instance when it is preparing for shutdown. You have roughly 45 seconds for those recipes to be executed. So you can assign specific items there to perhaps make sure that you copy logs onto a central location before you shut down the instance. Now, the next question we had was around monitoring and how this works with OpsWorks and the different stacks and layers. So the question was, how can I monitor a layer or a stack as a whole instead of just single individual instances? And OpsWorks integrates with CloudWatch, and out of the box you get 13 metrics for the entire stack, a specified layer, or a specified instance. And you can view those metrics on the US East region. That is regardless of where your application is actually running. So perhaps your OpsWorks stack is located in EU West 1, but you would see all those metrics in US East. And based on those metrics, you can create alarms so that you can, for example, be notified when a certain value goes above a certain threshold. Another question we got was around managing different environments, having a development environment, a staging and production, and how to make sure that we work seamlessly with those environments and we push code from one to another. And there are many different approaches for that. Here I'm showing just an example where we are using Elastic Beanstalk, but the same could apply if you're using OpsWorks or Cloud Formation or a combination of those. Essentially, you have perhaps a Git repository that your developers use to manage the code, and you have different branches of code. So you might have different projects, you might have a separate branch for debugging, or you might have a large project happening on a different branch. Now, at any point in time, you can push different versions of your application to different environments. So if you might have different testing environments where you have a separate version on each of those, and this is useful when you want to run tests in parallel. But essentially, you could also use the same approach to push the newer version of the code first on a staging environment, and once you're happy with that, run all your tests, you can automatically push that into production environment. Now, another approach here is to do what we call blue-green deployments. In this approach, we treat each environment as if it was a software component. We stop thinking about environments and servers as hardware components. We really treat them as software components that we can bring up and terminate at any time. So with this approach, we launched a completely new environment. Let's call it the green environment, in parallel to the blue environment that we have running. Now we can quickly route our traffic to the new environment that runs the new version of our code, version 2. And suddenly all of the users of the application are experiencing the new features of our application. The two environments, of course, have to share the database. So if you're introducing any changes that break the compatibility between the schema, this is something that you need to plan for. So you need to make sure that version 1 and version 2 of your software can both function with the same database schema. Now, if something goes wrong, and despite all the testing that you've done, you realize that there are maybe many errors on the logs, you can quickly go back to your old environment. Once you are happy, you can actually terminate the blue environment and stop paying for that. A more sophisticated approach would be to, instead of sending all the traffic to the new environment at once, would be to gradually use Route 53 weights to send a portion of your traffic to the new environment. And this is a lower risk way to do deployments, because now you are only affecting perhaps 10% of your users. If you discover that there's something wrong, you can quickly roll back. Something that is important when you are working with multiple environments is to make sure that you don't hard code any environment specific variables into your configuration. For example, your staging environment or your test environment might have a different database endpoint from production, and you don't want that to be part of the configuration file. A way to achieve that is to store the application config in environmental variables. And for example, if you're using Elastic Beanstalk, it is easy to define those either through the console or through EB extension files. So you can define your own parameters, and then you can consume those from within your application. This is just an example I'm showing here with Java consuming an environmental variable that we defined in Elastic Beanstalk. And here is an example where we define multiple options. So I could have a different host name for the CDN for the different environments, and maybe I don't want to use Memcached on one of those environments, etc. So the next question was about CloudFormation secrets. How can I securely manage secrets of my application, perhaps user credentials for the database? and you can use CFN Init to use roles to download files that are in a private bucket. So you could have a private bucket on S3 and assign access to that bucket to a specific role. And then you can assign that role to your EC2 instances so that the instances that should have access to that file can download that file and parse it and use it in the application. And this is how it would look like in Cloud Formation. You define a specific role that has access to a specific file on S3. You can do similar things with OpsWorks. We described before that Elastic Beanstalk allows you to create environment variables. You can do the same with OpsWorks. So you can create environmental variables, define them through the console. You can update those at each application deployment, and you can define some of those as protected values so that they are not visible on the console or through the SDKs or the command line tools. Alternatively, you can use encrypted databags on OpsWorks if you're using Ceph 11.10. You can create a databag, you can encrypt it, and then you can add the encrypted values in your custom JSON or in the definition of your stack in OpsWorks. And then you're going to need to upload just the key for the encryption and the decryption of this file to S3. You can protect it with server-side encryption. And again, you can use the same approach that we described before with Cloud Formation to access that file only via designated identity and access management roles. Then, from within your recipe, when you want to consume that information, you will decrypt that using the encrypt databag item function of Ceph. So the next section is about the automated centralized logging.
Thanks, Andreas. This is Lee again. So we're going to talk about automated centralized logging. This was a topic that was brought up in the last webinar. What we're going to talk about here is how to get your logs that are on your EC2 instances into a central location. This may be for durability, so you've got those logs no matter whether the instances are being scaled and therefore would be terminated at some point. You've got all the logs in a central location. It also allows you to do monitoring and performing metrics and alarms against those logs. So earlier this year we announced a CloudWatch log. So this works within the CloudWatch system, but it allows you to put into the CloudWatch system a log, your log entries. Now you can perform these two different ways. One is that you can use the API, and we have an API in the CLI command line to be able to put log entries into the CloudWatch logs service. You can also use two applications that we provide. One is for the Linux, is a logs agent, which will monitor log files that you configure it to monitor, and will send those in batches into the CloudWatch log service. For Windows, I mentioned earlier the EC2 config service. This has got the ability that you enable, by default it's not enabled, but you enable it within the EC2 config application. And then it will send both log files generated by applications, but it can also send Windows event logs and also performance counters into the CloudWatch log service. Once it's in the CloudWatch log service, it's stored durably, and you can specify how long those log entries stay within the CloudWatch log service. And you can also then set up search terms on those CloudWatch logs events, such as looking for error codes, looking for transactions, and you can then define CloudWatch metrics, which gets put into the CloudWatch system whenever these text terms appears. And from there you can set alarms. So for examples of being able to set, you could set that if a particular error code appears more than so many times within an hour, raise an alarm. Or for instance, if your transactions on your ordering website drops below a certain number, again you can send a CloudWatch alarm to monitor you to actually check your application. And just moving on, we're going to talk about Amazon Workspaces, and I'll hand you over to Ian.
So this is the final section of the session today where we've got content prep for you. We've not had a whole lot of questions, so if you do have any questions that you want us to cover in the remaining time that we have, please do submit those via the Q&A panel and we'll get to them. Amazon Workspaces, this was raised with a little bit of a non-specific question actually at the end of the last session. I think there was just a desire to know a little bit more about it and maybe for us to tell you a little bit more about Amazon Workspaces. And in very simple terms, it's a service that allows you to provision cloud-based desktops. So for end-user computing in the AWS cloud, delivering a Windows 2008 desktop experience to your users with all the sort of familiar characteristics of AWS, really. You don't have to buy any hardware, you don't have to provision anything, you just pay by the month for the particular bundle of desktop system performance, let's say, and software that you want to make available to your users. And one of the common use cases for this actually is for development use cases where you may have dev teams that you want to deliver a particular tooling environment to, which is sandboxed, which is secure, and which is elastic, because you might scale those development teams in response to particular software delivery initiatives within your organization. And Workspaces provides quite a good platform for that, because you can sort of ring fence those resources, make them available to the developers through a secure remote interface when you're running your projects, and then obviously terminate the resources when you no longer need them, potentially archiving assets from the desktops into Amazon S3 for long-term durable storage. Now we're going to have a webinar which is upcoming later in November, where we're going to focus for an hour solely on Amazon Workspaces. So I'd really like to encourage you to register for that and come along and join us if you want to learn more about this service. So we'll be focusing now on how you create workspaces, how you can build them into the Amazon Virtual Private Cloud construct and apply security policies to your workspaces, or place them adjacent to other high network workloads that you might be running, say Redshift clusters or Hadoop EMR clusters that you might want to create in the cloud. You can integrate those with workspaces really neatly because they use the VPC for deployment. We also just this week announced the new feature where we are now enabling you to create golden masters that are used as a basis when you create new workspaces environments for users. That was covered just in the last couple of days on Jeff Barr's AWS blog. So maybe we'll also find a link for that in a second and share that in the webinar interface with you so you can take a look at that if you're interested in it. But as I say, join us on I think it's the 18th of November. You can see the details in the background on the slide there. On the 18th of November for the Workspaces Masterclass. And I'll just pop the link on your screen now so you can register for that if you're interested in doing so. Okay, so that concludes everything that we have for you during the session today in terms of prepared content. We'll just take a look at a couple of questions that we've got and see if we can give you some more detail on those questions during the next 5 or 10 minutes. As usual, we're going to switch the webinar into Q&A mode now at the end. My colleague's going to do that in a second. And when we switched into Q&A mode, you'll see a rating panel there. We'd love to get some feedback from you about what you've thought about today's session, whether it's been useful for you. You can give us a score from 1 to 5, with 5 being the best, just to let us know how you think we've done. And if you've got any, let's say, qualitative feedback, you want to leave us any comments, then feel free to do that in the Q&A panel, as well as taking questions. We'll also take a few comments. So just to look at a few questions that we had today. There was a question about what is the best external tool that you can use to manage CloudFormation templates, potentially one that can be used with other virtual environments. So the answer to that really is there are a lot of tools, and maybe the best tool is one which you may already have some familiarity with. For example, most of my development experience has been in Python, at least recently. And there's a Python tool called Troposphere, which can programmatically generate CloudFormation templates using a Python-like definition language. So that's my favorite tool in terms of programmatically developing templates. I also have a generic JSON editor on my Mac called Cocoa JSON editor, which just gives a very kind of mistake-free environment for creating JSON files manually, but with structures which are defined and maintained within that particular tool. So you can use a generic JSON editor, or you can use a template creation tool. There are also some other some other software services that sit on top of CloudFormation, some of which have been developed by the community, and some of which are part of configuration management tools like Ansible as modules. So you might want to take a look at those as well. We don't really have a recommendation at AWS but you can certainly look at what's out there in the landscape and choose a tool which is good for your experience and also fits the particular use case that you've got. I think that would be our recommendation. Matt asked us about using NuGet packages for installation on a Windows host. So can you install or extract NuGet packages or only use zip or MSIs? And the answer to that is CloudFormation doesn't currently support NuGet packages natively. You can, of course, use a bootstrapping command to install NuGet, potentially unzip NuGet packages, and then run the NuGet install command to install them on your system. So that's a workaround, if you like, for using a higher level deployment tool together with CloudFormation. And that would go for any sort of package manager on Windows, I guess, and certainly any package manager on the Linux platform that you might wish to use. That's a good question. Does Workspaces require stable internet access to work? I think Andreas is writing a response for that at the moment. But of course, yeah, you need a reliable internet connection in order to use any kind of remote desktop service. That's pretty obvious. So broadband connectivity is what Andreas has said in his response in order to log into your workspace. I think if you look on the Workspaces product detail page, you may find some information, more specific information about bandwidth requirements for the service. And also bear in mind that it uses the PCO IP transport. So generic information about bandwidth requirements for PCO IP would also be applicable to Workspaces. If you want further detail, I would advise that you raise a question or post a question in the Workspaces forum on the Amazon Web Services discussion forums, which you can find on the website. And if you do post a question in one of those forums, you typically find you'll get an answer straight from our product team or from one of our engineering team members. So it's a super good place to ask questions if you want to get directly to the technical teams at Amazon Web Services that are working on building these services. It's also worth clarifying that the workspaces are persistent. So even if you're not connected, your workspace will be left in the state that you left it in. And when you reconnect to it, you'll find it back in that state again and available for you to continue whatever you were doing before. So it's a good tool for applications that you might use transiently, but you might not want to set up every time you use them. Okay, I think that's everything that we have in terms of questions that we're going to come to in the session today, because we're approaching 10:40 a.m. now. We're slightly overrunning the time that we allocated. So I'd like to thank you for joining not only the session today, but if you've been on the rest of the DevOps series that we've run, I'd like you to thank you for joining the whole series. This has been the first time we've run this particular program of events here in AWS in Europe. We're pretty happy with it. I hope that it's been useful for you guys as users of the services or potential users of the services, and most importantly, we really hope that you've learned something from it and it's extended your ability to get value out of using Amazon Web Services to run your apps and manage your environments. So I'd like to thank you for joining the sessions. You can see a couple of social media accounts in the links page, one for the AWS Twitter, which is at AWS Cloud. If you follow us there, you can stay up to date with AWS news and announcements. We have reInvent, our global user education event, coming up in a couple of weeks. So it's a good time to follow AWS Cloud and stay up to date with potential new service launches that might be happening during reInvent. I think it's a pretty fair guess that will be a few of them. So you can keep up to date with those if you follow us at AWS Cloud. And if you want to stay up to date with our education program here in the UK and Ireland, or in the European time zone in the English language, maybe more generally, find us at AWS_UKI on Twitter. And we do reshare some of the stuff from the AWS Cloud account in a more friendly time zone for people that are based here in Europe. But we also use that for notifying about our public events program and about future webinars and education events that we might be running as well. So follow us at AWS_UKI for that. Thanks for joining us from all the team here. We'll see you for another AWS webinar very soon. Thank you very much. Bye-bye.